Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day everyone. Okay, so today we come to week number 5 asynchronous lecture session. Okay, and today also we are going to complete chapter 2. If you are aware, kita punya chapter 2 ni tajuk dia limits and continuity. So our last class on Thursday we have completed the limits punya part. Alright, so for today we are going to solely focus on continuity. Okay, so continuity of a function. So this continuity memang sangat-sangat berhubung rapat dengan limits. Alright. Okay, so for today, by completing, when you are completing viewing the video, this asynchronous class, okay, you are able to understand what is continuity of a function, and the second learning outcome for today is you know how to determine the continuity of a function. Okay, so make sure bila dah habis tengok video ni, you are able to understand this too, faham apa itu continuity of a function, and the second one, how to determine the continuity of a function. Alright, so dekat sini basically yang ditunjukkan dekat sini, okay, adalah definition of a function. Okay, you don't have to memorize pun apa maksud, nak hafal apa semua tu tak perlu. You just have to understand apa maksud continuity of a function. Maybe it is hard for you to understand baca macam ni. Okay, kalau saya pun at first sight bila baca ni dengan keadaan saya tak berapa nak faham, so it's a bit hard for me to understand the sentence here. Tapi tak apalah, kita baca je sekali lalu. Nanti saya akan explain by showing the graph. I'm sure when you read again, you are able to understand it well. Okay, so this by definition, a function f, okay, is continuous at a. At a ni maksudnya at x equals to a. Kita tahu kan, function we have fx, okay, y equals to fx kan. Ni adalah function kita, dan function ni sebenarnya adalah graph kan. When we have x kat sini, we have fx. So the function ni, fx ni relies on x. Dan kat sini dia kata a function f is continuous at a. At a ni refers to at x equals to a. A ni boleh jadi kat mana-mana je lah. Okay, so it can be here ke because it's a variable, right? Is continuous at a. It is said that the function is continuous at a if limit fx as x approaching a is equals to fa. Sebenarnya dia menggunakan konsep limit yang kita dah kita belajar sebelum ni. Limit fx as x approaching a is equals to fa. Dan kalau dia satisfy this condition, maksudnya at point a here x equals to a, the function is continuous. Kalau dia tak satisfy this condition, maknanya at x equals to a, the function is discontinuous, ataupun dipanggil a point of discontinuity. Okay, boleh faham tak? Okay, maybe hard for you to understand now. Okay, dengan baca ni, now I'm going to explain from graph point of view. Okay, daripada graph nampak sikit lah saya rasa. Okay, katakanlah saya ada macam ni. Okay, we have here, we have x and we have fx. Maksud continuous ni kan, kita ada function atau kita ada graph yang mana function tu continuous. Dia berterusan, dia tak ada pecah apa-apa. Dia just go macam ni, katakanlah macam ni graph tu. So it's continuous. There is no hole, no donut, apa-apa. The graph dia tak ada asymptote, tak ada apa-apa. So this is so called as continuous. Faham tak? Tapi kalaulah graph tu, if let's say the graph that we have macam before this kita ada graph macam ni, lepas tu tiba-tiba dia stop kat sini. Lepas tu dia start balik kat sini. For example like this. This is what we call as there is a point of discontinuity. Dia ada breaking point kat sini. Dia tak continuous anymore. boleh faham. Tapi ni, yang ni kita boleh kata dia continuous lah, because dia line clear kat sini. It just go up like this, or maybe here kat sini. Just that the point of discontinuity is over here. Boleh faham? Ataupun salah satu lagi contoh that I may give it to you is, katakanlah macam sebelum ni, we have vertical asymptote. Remember? Okay, we have a vertical asymptote. Let's say the graph is macam ni, macam ni. For example, like this is the graph. So maknanya the graph is discontinuous at x equals to 0 kat sini. Sebabnya the graph ni dekat sini tak ada apa-apa. Okay, it just goes up here, tapi kat sini dia tak ada graph defined over here. So at x equals to 0 also here is considered as a point of discontinuity. Boleh faham? Okay, kita tengok point X sebagai location where does discontinuity happen. Where does the continuity happen? Okay, apa kaitan dengan yang ni? Okay, apa kaitan dengan yang ni? Sebenarnya, for us to determine the point of discontinuity ni, kalau macam graph tadi yang saya tunjuk tu, dia smooth je kan? Okay, at x equals to a for example. Okay, what is the value? There are 3 conditions for us to determine macam mana nak decide whether the function is continuous or not at x equals to a. Okay. Okay, the first one is you have to check, okay, whether fa is defined. Maknanya when the value of fx when x equals to a, ada tak value dia? Adakah dia exist or does not exist? Semua orang dah faham kan apa maksud DNE, right? There's a possibility that the function does not exist at x equals to a. Kalau dia does not exist at x equals to a paling awal, maknanya dari awal lagi the function is confirmed is discontinuous. Okay, and the second one, you check adakah limit fx as x approaching a exist ke tak. Macam mana nak determine ni? You have to check lah, limit from the left, limit from the right. Okay, sama ke tak? If it is sama, then only we can say that limit fx as x approaching a exists. Dan ketiga, you compare number 1 and number 2 here. Adakah fa yang define tu value dia sama tak dengan limit yang you cari tu? If it is sama, okay, the value of f equals to the limit of f at a, then confirm at x equals to a is continuous. Okay, at x equals to a is continuous. Okay, for example kat sini kan kita ada graph. Okay, this is our x and this is our fx. So nampak at x equals to a, apa-apalah value dia kat sini you masukkan, maknanya value dia exists. Okay, we may say this value is fa lah. Okay, fa. Then limit from the left, limit from the right pun is pointing to the same point. Okay, it's pointing to the same point. So maknanya is also fa. Then from here we can say limit fx as x approaching a is equals to fa. Okay, so maknanya ni at x equals to a, yes, it is continuous, and in fact for this graph it's continuous everywhere. Senang je nak determine whether the function is continuous or not. You tengok je dalam graph ni ada tak lubang-lubang ke, asymptote ke. Kalau tak ada lubang, tak ada asymptote, then confirm the function is continuous everywhere. Okay, boleh faham tak? Okay, alright, so now kita pergi kita pergi dengan lagi details. Let's have a look at example 13 here. Is this function continuous at x equals to 1, 2 and 3? Saya rasa tengok example ni you all lagi faham lah kot. Alright, so now let's have a look at x equals to 1 first. At x equals to 1. So as I said just now, there are 3 steps for you to decide whether the function is continuous or not at a point x equals to a. For this case, a is equals to 1 lah. Okay, ni x equals to 1. Alright, so first of all, you have to decide, okay, or the first step is to determine what is f1. Apa value f1? Okay, mana x equals to 1? Here we are, this is x equals to 1. Sekarang awak fokus hanya dekat sini. You just focus over here and have a look. There are few possibilities here. Okay, what is f1? What is f1? Yang di lubang putih ke lubang hitam? Definitely hitam kan? I've told you many times, hitam ni maknanya it indicates that the function is defined at that particular point. So f1 over here is equals to 1. Alright, so f1 is equals to 1. Okay, then what is the next step? Okay, function tu define. Bukan tak define dia define. Because ada lubang hitam dekat x equals to 1 over there. Alright, the second one is limit fx as x approaching 1. So for this case, you have to consider both cases. First case is limit fx as approaching 1 from the left. Okay, from the left, mana arah kiri? So datang dari arah kiri, check apa value that of value of fx as x approaching 1 from the left. Okay, which curve should we regard? Yang mana patut kita tengok kat sini is this curve lah. Ini yang membawa x dari belah kiri. So as x approaching 1 from the left, as you can see, is approaching 0. Betul? Okay, dia approaching 0. So here we are, we have 0 over here. And then we need to consider also limit fx as x approaching 1 from the right. Okay, from the right, dari arah kanan, adakah also 0 dari arah kanan? No, we don't have any curve approaching x approaching 1 from the right yang menyebabkan is equals to 0. But instead we have as x approaching 1 from the right, daripada arah sini is regard to this curve, so is approaching 1. Kan? Is approaching 1. So what shall we conclude for limit fx as approaching 1? Sama tak dua ni? It is tak sama, right? Betul? 0 dengan 1 mana nak sama? So limit fx as x approaching 1 in conclusion does not exist. Betul? Because apa? Because limit fx as approaching 1 from the left is not the same as limit fx as approaching 1 from the right. So what can we conclude at x equals to 1? Do we need to proceed to the third step? Perlu tak kita proceed to the third step? Third step is to decide whether limit fx as approaching 1 is it equals to f1 or not. Do we need? No need, because kita dah stuck dekat step number 2 because the limit does not exist. Okay, since the limit does not exist, so confirm the function is not continuous at x equals to 1. The limit is not continuous at x equals to 1. So maknanya, so in conclusion, okay, you kena buat conclusion ni, fx is discontinuous, saya tulis short form je, at x equals to 1 because kena justify the reason, because limit fx x approaching 1 does not exist. Boleh faham? Okay, so first step kita decide dulu what is f1. Second step kita cari limit, and for this for at x equals to 1 ni, dekat step number 2 dia dah stuck. Okay, dah failed to satisfy the condition. So we don't need to proceed to step number 3 sebab memang takkan dapat jawapan lah sebab limit tu tak exist. So it straight away jump to the conclusion saying that fx is discontinuous at x equals to 1 because limit fx as x approaching 1 does not exist. Okay. Okay, now let's proceed to point at x equals to 2. Okay, we proceed to the point at x equals to 2. Okay, at x equals to 2. So same, we decide first what is f2. Okay, apa value when x equals to 2? When x equals to 2, yang mana nak tengok ni? Point lubang putih donat, cincin ke, whatever you hold kat sini, atau point hitam? Definitely we're going to choose this black hole. Okay, ataupun black point here. So we f2 is equals to 2. Okay, tulis f2 is equals to 2. Then we proceed with limit fx as x approaching 2. Okay, then we consider both sides. Limit fx x approaching 2 from the left, and the second one, limit fx x approaching 2 from the right. From the left, what is the value? From the left, this is x equals to 2. Coming from the left of 2, tengok dekat curve ni, so it's equals to 1. From the right, okay, kita ada curve yang sama sebenarnya. So from the right is approaching 2 is also equals to 1. So this time limit from the left and limit from the right sama, right? Sama. So in this case, what shall we conclude? Limit fx as x approaching 2 is equals to 1. Okay, we have value for condition number 1, which is f2 is equals to 2. And we have also a value defined for condition number 2, where the limit exists, limit fx as x approaching 2 is equals to 1. Now let us compare step number 3. Does limit fx as x approaching 2, which is equals to 1 here, is it equals to f2 class? Sama tak dengan f2? Our f2 is 2. Is it equals? Tak sama, betul? It's not the same. Limit fx, which is equals to 1, is not the same as f2, which is equals to 2. So what shall we conclude? Again here, fx is discontinuous at x equals to 2. This time because limit bukan does not exist, limit exists. Limit fx as x approaching 2 is not the same as f2. Faham It's not the same as f2. Okay, limit exists, f defined, tapi dia tak sama. So with that, maksudnya value tu tak exist. Limit tu tak exist. This bukan value to exist, limit to exist, tapi the function is discontinuous sebab limit tak sama dengan f2. Alright, so now let's proceed to example 3. Example 3 pula. At x equals to 3. Okay, now saya nak pakai hijau pula. Okay, let's write at x equals to 3. Okay, at x equals to 3. So same step, we decide first what is f3. Okay, what is f3? So f3, tengok kat sini, what's the value? Mana ni 3, so it goes up, cari point dia. So you see f3 terang dan jelas lagi is equals to 2. Okay, then we decide limit fx as x approaching 3. So we consider both cases. Limit fx as approaching 3 from the left, and the second one, limit fx as approaching 3 from the right. From the left, ni tengok, from the left, kita tengok ni is equals to berapa? 2 lah kan. And from the right, ni curve ni, tengok curve ni yang membawa ke point 2, coming from the right of 3. Ni 3, x equals to 3 kat sini kan. So what is nilai y dia? This is y equals to fx is also equals to 2. So sama tak limit from the left and from the right? Yes, sama. So with this we conclude that limit fx as approaching 3 is equals to 2. So what is the third step? Third step is limit fx as approaching 3, which okay, is it equals to f3 this time class? Sama tak? Yes. Nampak? f3 is equals to 2. Limit fx as x approaching 3 is also equals to 2. Sebab sama ni saya nak tukar sikit, nak suruh nampak. Okay. So sekarang ni we may conclude limit fx as approaching 3 is equals to 2. This is equals to f3. So okay, fx is continuous this time. Is continuous, okay, at x equals to 3 because okay, limit fx as x approaching 3 is equals to f3. Boleh faham? Okay, nampak tak? Alright, so with this kita dah siap example 13. Alright, so that's it for the first part of today's asynchronous lecture.